We are told that air is escaping from spherical balloon at a rate of 2 centimeter cube per minute. So mathematically, this is equivalent to dV over dt. That is, there is a change in volume with respect to time. So we represent this as dV over dt equals negative 2 centimeter cube per minute. And now using this information, we have to determine the rate of change of surface area of the spherical balloon. So first, let's determine dr by dt using the volume formula. That is, the volume of a spherical balloon is 4 by 3 pi r cube. I'm going to differentiate both sides with respect to time. So when I do that, I get dv over dt. This equals 4 by 3 pi, and then we have to differentiate rq with respect to time. So first we apply the power rule. When you do that, we get 3r squared times of differentiation of r with respect to time is dr over dt. Now let's solve for dr over dt using this equation, and we will also plug in dv by dt equals negative 2 into this equation. So when I do that, I get negative 2 equals, we can cancel these threes. So this becomes 4 pi r squared dr over dt. Let's solve for dr over dt. Dr over dt equals negative 2 over 4 pi r squared. So this basically becomes negative 1 over 2 pi r squared. So now we have found dr over dt, that is negative 1 over 2 pi r squared. And using this, we will find the rate of change of surface area. So here I write the formula for the surface area, that is 4 pi r squared. I differentiate both sides with respect to time. So this is ds over dt. And basically this represents the rate of change of surface area. So this equals 4 pi times of, we have to differentiate r squared with respect to time. So first we apply the power rule. When you do that, we get 2r, and then applying the chain rule, we had to write down dr over dt. Now let's plug in the expression for dr over dt, that is negative 1 over 2 pi r squared. So therefore this becomes 8 pi r times of negative 1 over 2 pi r squared. So let's cancel the terms. We have pi cancel with pi. This 8 goes into as 4 times. You can cancel 1 power of r like this. Let's write down. So therefore we have 4 times of negative 1 is negative 4, where in the denominator we have r. And we have to determine the rate of change of surface area when the radius is 1 centimeter. So we plug in r equal to 1 into this. So I put 1. So therefore this becomes negative 4. So this is the rate of change of surface area. That is, since we are getting negative, it's basically shrinking, and the unit of this is centimeter square per minute.